So welcome to the Mobile Network Forensics Workshop. My name is Eric Fulton. I work for a company called LMG Security. And I'm just going to dive right in. We've got roughly 3 sessions for this now. Originally on your program it says 2 sessions, but I'll now be extending into the 3rd one. It's been a bit interesting. I initially wrote this with a lot of time in mind. I think I originally aimed for 4 hours, and then I cut it to 2 hours, and now it looks like it's going to be an hour and a half, or 2.5 hours. So forgive me if it seems a little disjointed in timing, but it should be pretty good. So with that, why mobile network forensics? Basically, welcome to this workshop. This is a hands-on workshop. For the first hour, I'm probably going to distribute evidence. I'm going to try and give you guys time to make sure you get everything going. And basically, what I'm trying to do here is teach you guys network forensics based on mobile devices. The goal is to basically have you guys be able to analyze packet captures, identify that mobile devices were used, and be able to see some of the traffic that is being sent in and out, along with learning a lab and some other things. But I'll get to that in a little bit. The course creators, it was by my firm. We basically, we run a couple things online. It's forensicscontest.com. We also run the hugely popular network forensics puzzle contest at DEF CON. And I've got some CDs from the last one up here if you guys want to try your hand. It is a huge topic, and there's a ton of fun stuff to be learned. Here's the names of all the people online, and you can follow my Twitter. It's Trisket. Yeah. So to kind of talk about where we're going to be going, basically I'm going to try and begin with an introduction to mobile devices, the networks that they use, how you guys can set up your own labs if you want to basically try this yourself at home. I'm going to give some demonstrations, and this is where some of the disjointed knowledge came in. I was initially going to have you guys work through it with me, but then I realized for 2 hours there was just not enough time, so I switched it to demos. But now that there's more time, that means that there's more time to go into the contest. And so at the end of kind of me talking, I'm going to go through and try and work with you guys to do essentially a contest where you're looking through packet captures, using some of the things I've shown you, and hopefully you'll be able to answer them and win prizes. Now, if you're thinking to yourself, I have no idea what's going on here, you know, this is all going above my head, no worries. I'm going to take 10 or 15 minutes so the people that are ahead and know what they're doing can go through and try and compete against each other. And then I'm going to go through and kind of show you guys how to answer the questions that were asked. We're going to be doing some great things, analyzing GPS, all this other stuff. To give you guys kind of a background on the contest, and this is going to be coming in the 2nd hour, basically it's following off of our forensicscontest.com story. It is very, I don't know if hokey is the word, it's very tongue-in-cheek. It's not very serious. There may or may not be some, you know, non-continuities with the actual storyline, but the storyline is mainly meant to drive the actual contest. We're going to give you guys some PCAP files to look at, and you will be the forensics investigator. Can you solve it? I've got some great prizes. I've got some rubber duckies. I don't know if you guys are huge into these. I got a devil ducky and some Swiss Tech utility keys. They're not the greatest prize, I'll admit, but they're still pretty rad, and my hope is that you guys have something to take home from winning your forensic investigation. I'm going to be handing out some flyers talking about Network Forensics Black Hat Edition. There's going to be a 4-day course taught by my colleagues and the recent authors of Network Forensics book at Black Hat USA. And then I also brought along some old DEF CON CDs that have our puzzle contest. And so if you really are getting into this and want something to play on, these are great. I know at DEF CON, the fastest team, it took them a little over 5 hours. And that's some smart people working on it. So it should give you something to sink your teeth into if you're looking for a project. There's our awesome prize. And I've already kind of talked a little bit about this, the goals. What I want you guys to take home from this workshop, I want you to be able to build your own lab. Because there's only so much that I can do in providing you PCAPs and providing you how to analyze these. And then really what my hope is that you can go home and take out your own mobile device, your own laptop, Xbox, whatever. Take a look at the traffic and then take what you learn here and extend it even further out. It's a huge growing field. Network forensics is still in its infancy, and there's a lot of things to be gained. I mean, just recently, how many of you guys here have heard of, what was it called? Not SwiftKey, the Sprint, where it was exfiltrating every one of your keystrokes. What was that called? Carrier IQ. Have you guys heard about Carrier IQ? A few of you? Yeah, I mean, essentially what this was, it's not malware. It's classified as malware. But the carrier was installing this application that was sending basically a ton of statistics about what you're doing on your phone back to them. And unless you are, very closely looking at your Android, I mean, you can actually discover this if you did traditional forensics. You make an image of your phone and you're looking through it, or you can discover what they're sending over the wire with network forensics. And that's kind of where we're going, is looking at information that's been sent over the wire. So that's our huge goal. There are some caveats. This is just a teaser. I would love to teach you guys so much. I would love to go and cover the entire breadth of, clandestine networks, trying to exfiltrate data on non-typical standards, how to identify things, how to do net flows, all of this. But I've only got a limited amount of time, so this is going to be me trying to jumpstart you as much as possible. I can only go into such depth, and I'm also assuming you guys have a certain level of knowledge. I know in a room this large it can vary very high and very low, so it's my hope that for the people that are new to this, I can give you something to grab onto and learn, and for the people that are like, oh yeah, this is my job, I can give you something advanced enough to where you're interested. So with that, I'm going to distribute some evidence. What I've got here is a USB key loaded up with both the PCAP files and a live OS. And then I've got a friend that I'm going to have pass them out if he wants to come up. I'm going to pass on with these flyers. Basically, if you've got a Windows computer, you should be able to just boot, and if you just get one of these, one to each person, boom. You should be able to plug it in, boot from USB, and go into a custom Linux distribution that's got custom compiled Wireshark on it and our evidence files. How many people have Macs? Not too many? Oh, a lot. Of the people that have Macs, can you raise your hand if you don't have Backtrack and don't have Wireshark? Kind of. Do you have the Wi-Fi password, sir? Good, okay. Yes. I recommend you either get a virtual machine of Backtrack or something else, or get Wireshark. Because the evidence files you'll be able to access, but for everyone else it's been kind of pre-made. With this evidence, it's a bootable, yes?
Does it specifically have to be Backtrack or a SQL insertion?
Oh, that works. I use Backtrack as an example because a lot of people have it. And you have Wireshark on there as well, right? Yeah, okay, perfect. And the one thing to note is if you've got your own Wireshark, you want to use your own tools, just be aware some Wiresharks don't allow you to decrypt SSL streams. But I'm going to talk about that in a little bit. So you might be a little disadvantaged for the final one, but my goal is to have you work in teams. Forensic investigators rarely work on their own. And so I really want people to be able to work together and kind of collaborate on solving these. Personally, myself, if you don't need it and you've already got Wireshark and grep all these other tools, you don't necessarily need to use the live distribution. It's fun. It's there for the people that don't have it. You use format use as a USB key, actually. But there's two different partitions on it for this class. So there's the one partition, which is the bootable distribution. That's got the files on the desktop there for you. And then there is a separate partition that has the actual contest files. There's going to be some stuff that's not encrypted, the scenario, everything else. And then the actual PCAPs are encrypted right now, just because I want to give everyone a fair start. Probably in the next hour and a half, I'm going to give you the password and just say go. So those should be passed out right now. And if you've got a laptop, go ahead and plug it in. If we run out of USBs, I don't think that should be the case. That's awesome that the back is full as well. I would ask that if someone's able to already drag their files off, just to share. But be aware this is Black Hat, so make sure you trust them a little bit. Just a skosh. All right, I'm gonna let those be passed out while I continue talking. So, to kind of give you guys a little bit of backstory, basically the idea of mobile phones in your pockets, it used to be you had this phone that you made calls with. You had this phone that was basically used for texting and for talking, and that was about it. And as smartphones have evolved, incredibly so in just the past few years, more and more you're carrying a little, basically, data center in your pocket, a tracking device in your pocket. And the idea of this being that you have a GPS device that is connected to the cloud that you have all of your important documents on, which is something you didn't have before. And I'm going to look at this from a couple perspectives, both from the personal privacy perspective, but also from the I'm managing my corporate network and don't want personal devices everywhere perspective. And so the idea of this is that there's a number of things that these phones have. They've got personal information, email information. They've got VPNs, work documents, cloud accounts, all of these are being communicated over a network. And they're communicated via either two ways, over the cellular network or over a wireless network. And this is a huge point, is that what we really need to know is the data is the same. Whether it's being sent over a 3G connection, 4G connection, or if it's being sent over wireless, the packets are the same. And so when we're doing our testing, what's nice to know is application developers aren't doing anything crazy clever, like don't send packets unless it's over a cellular network, because typically cellular networks are harder to man in the middle, harder to intercept. Really, these mobile devices are set to communicate whatever way they can to the internet. And that being the case, what we care most about are the packets. Not the T packets, though. The one of the data type. Sorry, this is my one European joke. Everyone likes T here. Sorry, that was my try. But the data packets. And so all of these are going over a Wi-Fi connection. Now, the easiest way for you guys to intercept these packets and look at them yourself is to send them over the wireless network. So we need to understand Wi-Fi just a little bit better. I mean, to step back, you could build your own cellular interception lab. I'm not going to be the one to stop you. I mean, hack a femtocell or pay $50,000 for your own cell site. That would be awesome. But you're still going to be collecting the same thing, packets. And so the easiest way and the easiest, lowest barrier to entry is through wireless networks. So to do kind of a quick primer, and I'm not even going to dive into the depths of how awesome Wi-Fi is. I mean, there was an earlier workshop on advanced Wi-Fi pen testing. You guys go to that? It was canceled? Just kidding. All right, I was going to say you could have learned about it there, but apparently that's not the case. I guess Google's your next best option. Okay, well, in either case, the very basics of the wireless connection are there's a number of different standards. Now, very rarely do you see the J networks, the Y networks, and these are all in ISO standard docs. But what we really need to know is these are the frequencies that you can capture on. These are the ways that data can be sent. Most typically, you're going to find it being sent over ABGN networks. But it's nice to be aware that there's some other networks. Now, and while these do have the same operating ranges, be aware that the specifications change in terms of frequency use, channel width, spacing, etc. But if you really want to delve into that, you can't go to the earlier workshop, but there's plenty of information on the internet and the ISO docs. And so along those lines, when we're setting up a lab, this is the configuration I used. Just as kind of like a very basic outline, I had a wireless router so that I could route my packets from the mobile device. I had a laptop running SSL strip, and then I had a number of mobile devices, a large number of mobile devices. You don't see an iPhone in there because that's what I used to take the picture. But looking through here, we'll see a couple Galaxy Tabs. Can you guys name the rest of these devices? Play name that device. Let's do it for Ducky. Who wants the English duck as I'm throwing it? All right, name that device. Close. Asus. Nope. Close. Not an iPad. What? Nope, not a Zoom. Huh? What? Oh, no. There's only so many tablets. Huh? Anyone? Anyone? Nope, not a Galaxy. Hint. It's made by a manufacturer from Eastern Asia. They make popular netbooks. Close. It's not Asus, but it sounds a lot like it. Yes. Who said Acer? There we go. Whoops. Let me go back one. I'm going to throw this at you. I'm sorry if I hit the guy in front. Yes. Success. An Acer tablet. We also have a, what is this? A hacked Kindle tablet with CyanogenMod 9 or Ice Cream Sandwich on it. One Galaxy Tab is running just stock, which I believe is not Gingerbread, the one after it, before. Yeah, Honeycomb. Yeah, run Honeycomb with a custom UI. The other one has been hacked to run Ice Cream Sandwich. We've got one running CyanogenMod 7. We've got one running stock Droid software. We've got an iPod Touch, a couple Acer laptops, my lovely EPC that I love, and then a MacBook. And then also we've got this right here is a mobile charging device and the wireless router. And that's the basis of the lab. I mean, really, what really matters the most is having the sniffing laptop properly configured, the wireless router, and the devices you're going to sniff. And so really that leads me to my next point of, we've already looked at the hardware. What's the software that we're looking at? Well, the sniffing laptop, I just ran BT5. Backtrack's just really easy. It's got most of the tools you need on it. It's kind of like the kitchen sink. The laptop is running in forwarding mode. Thank you, Moxie, for SSL Sniff. This is a magical tool. A number of self-signed CAs, and then I'm logging with TCP dump. And so the way you can kind of conceptualize what it's looking at is SSL Strip is running as kind of a man in the middle, so I can see all the encrypted connections. For the cleanliness of my packets, I set my sniffing laptop as the domain. However, you could also acquire them via ARP spoofing or other man-in-the-middle techniques. And it's routed through there out to the internet. And it's also running TCP dump, so I can capture all of the packets going on. SSL Strip is a just great tool, great for debugging. It's a little tough to set up, but there's great documentation online. Moxie's got some great documentation on basically setting it up so that you can have certs intercept. But if it's a little hard for you and you feel like going the easy route and you've got a lot of money, I guess you could just buy your own man-in-the-middle cert. Too soon? No? Okay, that was the joke on TrustWave selling wildcard certs to companies, but neither here nor there. So these are the exact commands that I ran. Basically just, I set my laptop into forwarding mode. It's now basically taking in anything on port 443, exporting it out to 999. SSL Sniff is running on that. And then SSL Sniff is logging, and I've got TCP dump on as well. So that's how I set it up. I'm going to take a moment. Any questions on this? Do you guys have any wondering how I did it or how to do it yourself? No? Perfect. All right, I'm going to take that as I did an awesome job. So I'm going to move into a demo. This one's basically tracking social network behavior. And going in with the hokey backstory, one of the main characters is Clearance Clearwater, or C. Clearwater, my apologies. And he's essentially trying to sell the Leap Pill, or a basic pharmaceutical item that gives you excellent hacking skills. And basically, we want to know who he's selling it to. And so the premise of this is we captured some packets while he was online at the local coffee shop, and we're going to use network forensics to the rescue. So let's take a look at it. What do we see here? Yes. He is talking over a secure connection. Thank you. You get a devil ducky for that. Nice. He's talking over secure connection. But one of the great things about this is he was talking through our SSL Sniff, meaning that we have the cert that we can use to decrypt that. So if you look in Wireshark, if you go under, and I'll have you guys, if you got Wireshark open right now, I'll just talk you through it. Otherwise, I'll be showing it later on as well. If you go to Edit down to Preferences, it'll open up a preference window, and you'll see on the left-hand side, there's a bunch of menu items, and you'll see protocols. So if you expand that, go all the way down to SSL, you'll see this screen. And it's different in terms of versions. I know the latest packaged version for Debian-based ones, it looks a little different. This is compiled from their source 1.7. But in any case, the idea is that what you need to decrypt these packets is an IP address of who's it talking to, the port, the protocol, and then the key file. And so if you see up here, I've got all of those already filled out. And probably this is one of my caveats to this. And I'm not really sure if there's anyone that knows anyone that develops at Wireshark. It's really cumbersome to decrypt SSL packets, especially if you've got a number of different ones. And thinking about it, that would be a really, really tall task to ask. But it'd be great if in Wireshark you could point it to your certificate directory and it would go through and decrypt all traffic that was encrypted with that. But I ask a lot. So all we need to know here is that we can decrypt SSL traffic. So when we do that and we look at it, all of a sudden all of that gray turns into beautiful green, in Wireshark at least. And this is done just by sorting by protocol type. And all of a sudden, this encrypted data that we get turns into GET requests, HTTP requests, and then, oh my, a POST request. So if we're trying to figure out what he's doing, we're going to go through, use our our network forensics instincts and look at the SSL decrypted stream. So here we are. This is actually what he's using to communicate with Facebook. So if we do some basic analysis on this, and can you guys see at the back? I know it's a little small. And I'll just read it aloud for you guys. We can see some things. We can see the refer. So he's at Facebook. We can see Facebook's internal SVN revision. I don't know if we need to know that, but we do. We can see what he's using. So he's using something Android. I believe this is the model number for the tablet that was being used. We can see what build it is, etc. And then we can also see the cookie and the post form. Now, what could we do with a cookie if we were evil? Yes, we could basically steal his session. And then what can you do with someone's stolen session? Evil things. Yeah. So that's one thing that we can see. Just by him connecting through us, we can now all of a sudden own his Facebook. I'm not going to go into how much fun I've had doing that to my friends. However, you could do that, and we can also see what he was typing. So if we look down here, it's kind of tough to see. It's HTML encoded. You can see the message text says, "It seems I am nearly prepared." For what, I guess? We don't know, but we can see what he posted. Now, looking through this and having already decrypted this, what's some interesting things we can do with this XHPC message text? Let's think from the corporate, let's think with our evil corporation mind right now. If you know what things to search for when people are posting to Facebook, what could you do with that? Huh? You could block the message. There's one thing. You could tamper with the message. That's pretty evil. I like that. Instead of every time you see the word hate corporation, you could change it to love. What else? This is my favorite evil one is, if you are intercepting everyone's traffic and able to look through it, should you have that processing power, you could have a little scrolling taskbar of what everyone is posting on their Facebooks. Kind of sketchy, right? But kind of cool. So you can all of a sudden see what everyone in your company is saying. Not necessarily whether or not you have the right to see that. Privacy issues aside, it could be done. And I'm a huge privacy advocate. So if you guys work for IT in big companies, don't do this. Anyways, I'll move on. We've got a success. We're able to scooch in, see that he's posting that, and we can do a number of evil things with that. So we've kind of already talked a little bit about this. You can do some evil stuff with people's Facebook traffic. You could change what they're saying. You could just not let them say it at all. You could have a list of everyone is saying in the company on their Facebook, and not even Facebook, LinkedIn, etc. And let's think about this. What other applications, from just having seen this applied to Facebook, what else could you do? Yes, to condense it down, you could fully own a person. I think that's the best condensed point. Basically, he said that you can use it to get their email. Once you have someone's email, because of our typical reset system, you have everything. I know this is black hat, but do we have any angelic ideas for this? What are some good things we could do? Nothing? You can help troubleshoot problems. If you're running your own application and you're not able to decrypt it yourself, you could look at that. You could be Dr. Phil for others. You could see if your friend is very sad on his Facebook and then cheer him up. Those are all great suggestions. So now I'm going to jump into a separate topic, and that is looking at malware. Malware is my next favorite point. Basically, what I did to do testing for malware, Mila, I forget Mila's last name. I think it's up there. Mila runs ContagioDump. ContagioDump itself is a website used to basically take a lot of viruses and malware that people have just sent in that you can take a look at, analyze, reverse. But she also started something called the Mobile Malware Mini Dump. So now we can go, and if you just Google, I don't have the exact URL up here, if you just Google Contagio mobile malware, it'll be one of the first results. You can now download your own viruses. So thank you, virus writers. We now have something cool to look at there as well. And if you really want to and you want to analyze the traffic, you can install it. And it feels so, so dirty accepting the installer saying, yes, you can read my messages. Yes, you can look at all my storage. Yes, you can look at all my phone calls. Oh, man. Users that just click OK to things perplex me. Essentially, on all of this, I've just installed and allowed this application everything. And it's just Android System Message. No one really knows what that is. And it's on the mobile malware tab, but we can analyze and look at what it is. It feels so, so dirty. And when I was searching for these, I actually came across this as well. I love memes. I don't know if you guys do too. But basically, viruses just scare me. But let's take a look at what this is doing. So, if we've installed if we have installed our malware and we want to know what it's sending in, exfiltrating, whatsoever, one of the easiest ways is to look at some statistics for your packet capture. In the lab, it's really easy to isolate it out. In a corporate network, it would be a bit harder, but if you're using advanced tools like NetFlows, etc., it's a little bit easier to isolate the top talkers. And that's what I'm looking at right here is the top IPv4 conversations. And if we look at this, just right off the bat, this address is strange. And mind you, you can't see what I'm doing on the other end. I installed this application, and then I set it down, and I boiled myself some water for tea. Came back, and I saw I had all these conversations going on that really shouldn't have been going on. So using my spider instincts, I decided to start doing whois lookups on all these IP addresses. And when we look at that, it's kind of strange that my tablet is now talking to Japan. I mean, not that there's anything wrong with Japan IP addresses, but the fact that my tablet's doing that for no reason makes you wonder. So I'm thinking, okay, well, maybe there's something legitimate. Maybe there's a Google server in Japan my tablet needs to talk to, even though it's not registered to Google. So I'm going to follow my suspicion and start looking at the traffic that's going across this. Now, looking at this, if you can see it, what stands out to you looking at this little snippet of packet? Nope, it's not the redirect. Oh, I'm hearing people whisper it to themselves. It's the GET request. That looks a little strange. So let's follow that, and let's look at the TCP stream. Okay, so here's the GET request that's going on, and I wasn't browsing the web, so I'm like, there really shouldn't be a GET request right now. And if we're looking at it, what just seems sketchy about this? All of it, yes. One of the top ones is the telnum and the madder. And because this device didn't have a telephone on it, it would just send null. Had this actually been my cell phone, it would have sent them my number and my email address. What could an evil person do with my phone number and email address? Yep, they can now phish me. I'm obviously an idiot for installing an application, so they can call me now and ask me to install more things or steal things. They can spam my mail account. Potentially, they can send text messages back and forth that charge me until I have no idea that I've just spent $1,000, texting Rome. A lot of things. And then there's one other thing in here that looks a little strange. Because if we look back, we're looking at an IP address. Oh, where'd it go? There we go. So we started off with just an IP address, but we never really knew what the host name was. So if we skip forward, we'll see, oh, this GET request is to a host I have never seen before. So let's take a look at this. Or if you're watching a Hollywood movie, zoom, enhance. We now have the host. So let's check it out on Dig. Okay, well, they're not doing anything super crazy here. I was hoping I'm going to find some facts, fast flux DNS, something sexy. No, this is pretty lazy malware writing. It's just going to regular DNS answers. So I'm like, okay, well, let's do some whois, see if it's different from the actual IP address. Aha! It looks a little different. It doesn't really look legitimate. I have no idea what pix55xx at a Yahoo account is registering this address. And if we also look, it was created pretty recently. I did most of my testing in late February, and we can see when it was last updated on and when it expires. But really, this was very recently created. And one of the reasons for this is they probably keep creating it wait until it gets taken down, and then sends a new one. So that's kind of sketchy that it's a brand new domain. And then the registrant name and email also look a little sketchy. I don't speak Japanese, but I don't think that's a real name. No, that was just a guess, but it doesn't look right. And then the email also just doesn't look right. So I decided to do some Googling. And Google, has the answer to life, the universe, and everything. And we can see that it links to a Japanese blog talking about that exact same registrant. So if we go there, we can see this blog has already identified that malware. They've done analysis on it, and boom, my answer is solved. Just that little bit of analysis, I've seen that something on my network is infected, where it's going to, the host that it's sending out, and the information that it's sending out. So knowing all of this, how could we identify said malware? I mean, if you own a large corporate network and have access to all the data flowing in and out, how could you identify malware? Yeah, that's a good one. Yeah, filter out foreign countries. If you're not doing business in China, why are your computers talking to China? That's a good one. What else? Yep, block known bad hosts. I mean, if you go through and look at this analysis, I mean, are you gonna block, where'd it go? Are you gonna block this host now? Probably, yeah. I mean, there's no reason not to. Yeah, what? Oh, Tor gateways. Yes, thank you. Yeah, you can definitely look for that as well. Anything else? Yeah, malware detection system. And I mean, and these are all great ways to get rid of it. And then in terms of looking at that, my hope is with this malware is to kind of open your idea or your minds to the idea that with mobile devices, you've got users coming in and out of your network, and you can't lock it down like you can with a desktop. You can't say, you don't get admin, you don't get to install things or click on things that you shouldn't. But when a person brings in their personal tablet, they've already clicked on the bad things, and now they're in your network. And now potentially there's external entities in your network, and you don't really know what you can do. I mean, you can try and lock down them plugging their things in, but if you guys have ever worked in IT, users always find a way around it, right? They always find a way to plug in their laptop when they really shouldn't. I mean, that's how a number of our SCADA systems are getting hacked is, they want to watch their Netflix and plug their personal laptop into the, top secret network, and that's when security controls break down. So with that, I'm going to jump into the contest. This is a hands-on contest. It's on, and actually before I jump into this too far, has everyone had a chance to get their USBs, the files are on their desktop? Raise your hand if it'd be easier if you didn't, if you're having an issue. A couple people having issues? Okay, I will come around and help you after I've set everyone else up and help you install it. Oh, do you need a USB? Oh, gotcha, okay. A little hard to do that. Mobile analysis on the mobile, meta. Okay, good. So we've all got the tools that we need. So to give you the backstory, it's all on there if you haven't had a chance to look at it already, but basically there's Leet Corporation, Dr. C. Clearwater, and the rest of the crew, and basically we're following along with what's happening. We've got some mysterious PCAPs that are planted on the thumb drive, and basically with a minimal amount of direction, I want you guys to look through it and see, just with these basic things, open it up in Wireshark. Do you see anything sketchy? Do you see anything interesting? Can you figure out how to open up the file and search for anything interesting? There's great prizes for whoever wins. Basically, I'm looking for you to, if you find an answer and you can see all the questions in there, just come up and whisper it to me. That's the best I got right now. And yeah, you're welcome to work in teams. It's going to be about an hour and a half competition. And then after probably the first half hour of people typing away, I'm going to go through the answers kind of one by one and show you guys how to get to the answers if you didn't. So with that, if you've got your TrueCrypt open and installed, and you've got the file prepped, the password to the TrueCrypt volume is, drum roll, can I get a drum roll? Maybe. Boom, cookies. So with that, if you're not gonna, if you don't want to try your own hand at it, or you don't have a laptop, I recommend getting a drink of water, using the restroom, and then probably in the next, actually, let's say after the break, I'm going to start going through each one of the 3 contest items. So have at it. Oh, and if you're going through and finding answers, I think I have enough prizes, so just run up here and let me know. Oh, it's on the file directory. Thank you, everyone. If you have questions, feel free to ask, too. And I think we're going into a, when's the break get back? Does anyone know? Quarter past. Okay, so at a quarter past after the break, I'm just gonna start going through and open up my own Wireshark and show you guys through. So all you guys competing, gotta rush to answer. Oh, yeah, Alone. Where'd the guy had? Oh, do you have any spare USBs? Oh, okay. If you could borrow it. Oh, also, I've got some DEF CON CDs up here as well. So if you're interested, these are encrypted. The passwords are on forensicscontest.com. You're welcome to take one. They've got a lot more puzzles that are a lot harder. So these are just kind of for fun. I'll just leave them up here along with my cards and some other stuff. All right, with answers on the table, I think it's probably time we can go through the actual thing. If you don't want to hear this, just cover your ears. But I think a lot of you were really interested in seeing what's going on. So let me just, that's really big. So let's kind of go over the answers from round one, if I can get that up. Oh gosh, I've got a monster-sized, hold on. This might be really hard to do on a small screen. Whew. There we go. That's a lot better. All right, let me find the questions as well. So this is round one. Oh, come on. All right, let's see if we can find this. No? There we go. Cool. All right, so for round one, Dr. Clearwater is planning his escape. We know he is on an Android mobile device with various applications. Investigators need to stay hot on his trail. Can you figure out his escape plan? Question 1.1. What is the name of the application Clearwater used to search for the flights? Someone that got that, just shout it out. Kayak. Yep. There's a number of ways we can find that. One of the easiest is to, if we go statistics and conversations, we can look at the different conversations that we're having and do who is lookups and kind of guess off of that. And it's probably one of these with large conversations. You'll also notice that delta is another one of those. A second way that you can look it up is filter for all HTTP requests. And if you look at one of the first gets, you should see that the host is Kayak, and that's the application. It kind of requires a little bit of inference. I believe somewhere else it actually says Kayak application. I just remember where that is right now. Boom. Do you guys have any questions on that question? Nope. Okay. Question 2. What is the date of his first flight? Yep, March 20th. And let's go through and find that packet. So there's one packet in here that had his entire flight plan. Now, let's see if I can find it. What? That one? There we go. So we just follow that stream. Here we go. We can see all of it is in the GET request. I'm going to resize this on my other screen, see if that makes it smaller. And there's many different ways that you can answer all these. Okay, it looks like that's not going to go any smaller. So hold on, just real quick, I'm going to see if I can make that monitor a little bigger. Nope. All right, well, I guess we'll just have to kind of go through this. So if we look up there, we'll see it's pricing it in. The trip type is one way, because if you're leaving the country, you don't need to come back. He's in the first class cabin, and it's all kind of in here. And we'll see we've got different segments. And I know a lot of you got tripped up it's hard not knowing what the airport codes are, but if you don't, you can kind of get rid of these just as HTML characters that are skippable. And it shows up as GEG to SLC, SLC over here to LAX, LAX to, where'd it go, ADL, and then OGG, or OGG to ADL, ADL to, where'd it go, or HNL to ADL, OGG to HNL, there we go. And each one, it's these three right here. Boom. And these are all URL encoded, which is kind of what the extra junk is. We can see that the vendor ID is Kayak, and it's mobile yes. So this is another way you could have found out it was the Kayak mobile app. We can see the currency, the price, and the date of his first flight. If we look in here, it shows, there we go, right there, which is March 20th, HTML encoded. Did anyone else get the answer in a different way?
Replay the URL, TV browser.
Yep, that's definitely a way to do it. You can just be like, all right, let's just paste this in and see what happens. A lot of you guys did that, which I found really entertaining, because sometimes it's not in the packet capture itself. You can just replay it out there. Someone else found a print request in there that they were able to reconstruct. It was really cool. So that's that answer. And then that also answers 1.3, the airport codes. And I think everyone got those. Do you guys have any major challenges while doing these first three? No. A lot of it's when you don't know the answer, what you're looking for. It's a lot of just staring at it until you kind of figure out what's going on. Nice. So let's go to round 2.
Would it be possible to write a Lua script to do the URL decoding in the Wireshark itself?
I don't know. Theoretically, I think so.
What I've seen something like this, but I'm not sure how to identify the strings which are supposed to be decoded.
It's true. Normally, I think so. The question was, does Wireshark have something that could automatically URL decode? And I always have just copied it out to somewhere else. Does anyone know? Did anyone find an internal URL decoder?
There was a page, public page, which was that.
Yeah, that's it. Yeah, that's usually, I just Google URL decode that you can paste something in. That'd be cool if there was a Wireshark plugin though that just kind of went through and stripped all that. Cool. Where was I? So for round 2. Before Clearwater left for his flight, he had to take care of some business with a prospective buyer for the LEAP pill formula. The packet capture begins at the start of his trip and ends when he reaches his destination. Now, P.S., do you guys like the hokey LEAP pill, all that stuff? Does that add to it, or should I tone it down? I'm going to take that as a keep going with it. Nice. So as we read this question, a couple of you guys had questions on question number 3. At what time did Dr. Clearwater arrive at his destination? There's a number of ways you could figure this out, but a hint of it is actually in the question where it says, this packet capture begins at the start of his trip and ends when he reaches his destination. So you could make the inference that the last packet is when he arrived. Or you can make the second inference that when the posts to the location server stopped, that's when he arrived. So let's look at this. I'm skipping ahead of myself, so we'll go back to question 1. Question 1 is, one time during his trip, the doctor used his mobile device to search for the name of his destination. What were his search terms? What were Clearwater's search terms? Big Sky Brewing. In Montana, yes. Yes, a fine local brewery. If you find yourself over there, it's delicious. So obviously, Clarence was looking for a beer. But how do we find how he looked for it? Huh?
Here we put in the packet by description.
Yep.
Query equals to, yeah, that will show up.
Yep, just search for query. Another cheating way to do it, if I go all the way up, is to just look through the, so many. There we go. Wait, did I open up packet 2? Yeah. Search through the protocol. Oh, this is really hard.
I mean, inputting the filter HTTP.
Yeah, there we go. There we go. So we find all the HTTPs, and this is really there's faster ways to automate through this with scripting, searching for query strings, etc. The basic easy way to check for it is to kind of look through these. Search terms. So one of them you could probably guess is a post, maybe. It's in here, it's one of these. Nope. That's him posting his geolocation. What should I change it to? Oop. And there we go. Thank you. That's very handy. So you can also use filter requests, and we can see all of the posts. Here we are. And it is in one of these. Is this it? Ah, there we go. Boom. So I went to the last, so to show you, let's do that again. Oop. HTTP dot, oop. There we go. Request dot method post. And if you go through and look at these, it was the last one to the was Moby combo. Follow TCP stream, and you'll see it was the query Big Sky Brewing. And you can also see where he searched for it at, right there. And he used Bing. Yes. I won't even make the funny comment. What? Just because you asked? You know what? Yeah, hold on, let's find it. Would you like some pirate stickers, sir? Boom, come up and get them. Woo! Do you have a Bing joke?
It's just going to Bing, isn't it?
Zing. If you guys didn't hear that, he said the answer to do you have a Bing joke is that's just going to Bing. Boom. All right, let me roll that over. So his search terms were Big Sky Brewing. He uses a terrible search engine. It's a surprise that he could find where he was going. Okay, that's enough Bing jokes. At the moment that the doctor searched for the name of his destination, what were his GPS coordinates? Well, they were in the same. And what's funny is, oh, I'm not on the internet. Does someone want to do a who is on this IP address? I'm just curious. I don't know if I can make it bigger. The IP address is 174.129. Amazon. Interesting. Now, if you guys were looking at this, why would this be posting to Amazon? Yep. Yep, they're using Amazon for their hosting. And the next question was, during the trip, Clearwater's mobile device alerted him that he was within 800 meters of another person. Based on the alert in the packet capture, was this person male or female? Female. For the quick, Pac-Man, what was her name? Samantha. All right, I'm hoping to hit you. Oh, yes, catch. My throwing skills aren't the best, but you got some Pac-Man band-aids. The name of, so if you look at the packet capture, let me see if I can find this.
It's 375.
All right, that'll make it easier. 375?
Yeah.
There's a way to do that with a filter, but I'm feeling lazy.
If you put HTTPS filter, it's one of the first.
What? Is it? Okay, I think it's frame equals. Oop. No? Sorry, I'm used to using ngrep for a lot of these. So just a quick aside. I know I had a lot of you guys use Wireshark. It's a great tool. It's very visual, but it's not the biggest for large data sets, because for all of these packets, it's really easy to scroll through and try and find stuff. What's super useful, and I don't know if the tool is on here, but other ones to install is ngrep and tshark. Those are both very useful. But frame 370, I'm just going to cheat and go to this. So I'm not very proficient with Wireshark, but it is very handy for visually understanding things. And you say 375? 315. Frame. There we go. Teamwork. There we go. Boom. Here we go. So we, huh?
I thought it was his TomTom navigation, the voice of his.
The voice that talks to you.
Oh, the voice that talks to him.
Voice stating, yeah.
Turn right in 300 meters. Yes.
Is it within meters? Something like that?
Huh?
Is it something like that?
No. Okay, another bonus question. This is for the Day of the Dead ducky. I love these prizes. What was the application used for GPS? Waze. Boom. So what Waze is, and I find this fascinating, it is a social GPS application. So its whole goal is to help you find other people that are using Waze to navigate. But it's really sketchy because random strangers can know exactly where you are at whatever time. Like, while I was driving with this application, Samantha just chose the wrong time to be using Waze when I was capturing these packets. It's like, Samantha's in 800 meters, 1,000 meters. And I was like, who's Samantha? But apparently she's another Waze user. And so we can see in here that it's telling me exactly that Samantha is arriving at, within meters, miles, default. Oh, where'd it go? Like, she's getting closer and closer. This isn't the one that says that, but it's really entertaining. And then the other thought of that is what a lot of people don't realize when they're installing these Android apps, they're giving this very specific information away to just random companies. I mean, if we already look at this, Waze is using Bing, Amazon, different ad servers, and now all these people know exactly where you are and exactly what time of day, exactly how far away from other people. It kind of raises some privacy issues.
I always ran that to another screen without being logged on, therefore it would be not easy to obtain.
That's true. You could try and be anonymous, but they know exactly where you are. Unless you're wearing an anonymous mask, and then you are the 99%. Yep.
Just a question about tshark and ngrep. Do you have to first go through Wireshark in order to decrypt SSL information, or do they have the option?
That's a good question, and actually that's a reason why I used Wireshark for the majority of these. I haven't found a way to decrypt packets in ngrep or tshark. So I need to email the developers of these. What I'm really looking for, so if you guys are feeling programmer-like, I would love for a tool that can automatically, and this is asking for the world, I would love for a tool that could automatically look at the certificates, look at the conversations, decrypt it, and then spit out a decrypted packet capture. Now, the amount of technical wizardry that has to make that happen is a lot. But it would be nice to have some sort of way to export SSL without having to go through all the different things. So as it is, as far as I know, Wireshark is the only way. Other questions? Good questions. Okay. And then at what time did he arrive at his destination in epoch time? The easiest way is to cue from the question and go to just the very last packet. And what did you guys get? And this is actually wow, that's going to take a while. Hold on. I hope none of you guys have issues with flashy lights. All right. So we can look at the very last one, and I believe it is a frame. There we go, epoch time. A fascinating thing that I discovered while doing this. Some Wiresharks are compiled without showing epoch time. They'll actually show whatever time you have. And as far as I can tell, because these gentlemen in the front had the issue that they had different times for the exact same packet. And I believe it's using the correct timestamps, but Wireshark applies the different time zone you're in to the packet. which I don't know. I feel like if you're doing a forensic analysis, if you're getting a packet capture from around the world, that can definitely throw off what you're looking at. So it's definitely a fascinating thing to note and something to be aware of if you're doing this professionally. But that's the quickest way to find epoch time. And then moving on to round 3. All right, let's find it. And my personal favorite. Did you guys have fun doing these? Yeah? I hope so. This is a lot of fun to make, and so it's a lot of fun to see you guys going through them. And you learn a lot. Round 3, it took me a while to do. Wireshark is incredibly finicky with SSL and how everything's done. We found out that even entering in capital HTTP versus lowercase HTTP for SSL, it won't. It's like, oh, capital HTTP is entirely different from lowercase. So there's some quirks here and there. But the best way to import the certificate is to go over to Edit Preferences, and then Protocols. And we'll want to go down to SSL. Oh my gosh, hold on. So my Mac actually doesn't have it. And some people ran into this as well. This is what you see when you have a Wireshark that's not compiled with the proper SSL libraries. So what I'm going to have to do is open up Backtrack. Exercises. Oh, that's the wrong one. Black Hat, round 3. Hold on. Running as root is dangerous. All right, we'll open this up. So we'll just do a quick overview again. To add an SSL certificate, it's under SSL, Preferences, Protocols. Where's my S? Oop. So, I have fat fingers. There we go. Oh, you gotta be kidding me. Apparently, my backtrack isn't working either. Oh, you know what? This is what you get for reinstalling your backtrack right before you do the presentation. In any case, that would be awesome. Here, I can show it on yours. Okay. VGA. All right, we're going to swap it out. Same packets. Oh, never mind. It's there now. Oh, that's what it was. I'm going to have to do this a little bit different. The screen is apparently cutting off where it would be. Oh, there we go. Yeah, sorry, I missed it. It is. Boom, RSA keys list. One thing to note, in older versions of Backtrack, or in older versions of Wireshark, this is what it looks like. In newer versions, there's a nice little menu item. Anyone that compiled it themselves or had it on their own computer, did they have the new version? Just curious, a couple people? Okay. The new version I'm finding is a little bit nicer for putting in multiple certificates. So it looks like the Wireshark devs are working a little bit on this. It's really cumbersome to try and enter multiple keys this way. But the best way to do it is, so we've got our keys list, and we need to know the IP address of where we're trying to look at. And with a very small screen, it's hard. There we go. So the best way to do it is to look through the destination IPs. On here, it's pretty easy. If you want to do it very thoroughly, you look at the IP addresses, do a whois to see if it's Facebook or whomever you're trying to do a man-in-the-middle or did the man-in-the-middle attack against. So if you did a whois on this IP address, it would be Facebook. And you enter it in right here. A fun aside, if you're capturing multiple packet captures of Facebook, you can't just leave the same key because Facebook load balances, so it changes the IP every time. So every time you do a capture, you have to re-enter this. That's a little frustrating. Again, I love that magic decrypting tool. But in any case, we're going to enter in the IP address here. So it's 69.171.234.64, comma. And then what we enter now is the port. And some people had issues with this. What do we want to enter in for the protocol? HTTP. Yep. And why do we enter HTTP and not SSL? Yep, because the HTTP is within the SSL, and that's what we're actually searching for to have decrypted. So then we'll enter that, and then the location of the cert. So it looks like it's in root, desktop. Actually, this will just be easier. Yep. Oh no. Let's try that again. Boom, we put in the actual certificate. Did you guys have a lot of issues with this, or once you understood what needed to happen, it was pretty easy to get a hold of? Pretty easy to get a hold of? Okay. Silence is acceptance. Wonder if I hit enter, it'll be okay. Nope. All right, I'm gonna move this onto my screen for a second so I can see it. Oh, I have no idea where this is going. Oh, there we go. All right, I'm just hitting apply. It's just because of the screen's resolution. It's really hard to actually see that. All right, yep, that works. All right, I'm gonna put it back on screen. So basically, I just hit apply, and once you hit apply, you're not gonna see that. You're presented with this, and a lot of people, they entered it and they did it right, but then they freaked out because they saw, oh, I still see SSL on here. But why are we still seeing SSL? Yep, there's plenty of SSL that doesn't have HTTP inside of it, and the actual protocol communication itself, like setting up the handshake, etc., is still going to be in there, and Wireshark's still going to display that. But any SSL data that has HTTP inside of it now shows up. Oh, that tops on that. Oop. Now shows up. So when we run a filter, what wasn't there before is now visible. Are you just figuring this out?
Wireshark is crashing for the third time.
Oh, yeah. Wireshark is also crashy. One of the frustrating things is, I mean, as I've said before, nothing else I've found decrypts except for Wireshark. So all of this analysis, one of the funny things is if you kind of knew what you were looking for, have you guys used strings before? Yeah, strings, it's dirty, but it works. You can just run all of the earlier packets in contest 1 and 2 through strings, look for the answer or look for something close, and you found it. That's one of the reasons why I chose for the round 3 to have something encrypted is you have to decrypt it and you can't just output it to strings, but it makes it a lot harder copying it through here. A lot of you guys, how many people ran into it was just a lot of text to run into, like to look through? A lot of people, right? So we're looking through here, and question 1 was 3.1. Let's see if we can get that back. There we go. Question 3.1 is, what is the doctor's Facebook display name? Yep, Clarence Darkwater. He's being clever. I hope you guys get a little bit of the humor in this. Maybe it's all for me. I don't know. But Clarence Darkwater was that. And so we can find that by looking through here. And one of the easiest ways, I'm curious, how did you guys find it? Yep. Yep. The easiest way is just to find the profile ID, type it into Facebook, and see what happens. Oh, 1 second. Oh, cool. Oh, and right now break time is going on. So if you guys want coffee, tea, crumpets, yeah. I'm probably only going to be another 10 minutes, if that helps anything. So looking through this, so the easiest way is just to get the profile ID, hit enter. It's also in the HTML in there, but that's a little bit harder to look at. For number 2, what is the Facebook ID number of the man who purchased the Leap pill? You guys have to shout it out. What was his name?
Keel Rogue?
Yes, Keel Rogue. He's such a rogue. He's a man that would buy the Leap pill. There's a number of different ways. I saw a lot of interesting ways to have this found. Oh man, actually, would you mind describing yours?
Just looked through most of the messages there, and I saw that get/messages contains lots of information inside it. So I just dumped the binary data, and I just truncated the content a little bit so that I get lines, so that it's easy to read. And I just saw a conversation there, from which I inferred all the other information.
Nice. Yep, that is definitely doable. Do you guys have any ideas on how you could automate that process? Encrypt, yep. If you could figure out how to get decrypted packets, I guess. Nice. Okay. Yep. All very useful. I think if we look at the post and follow SSL stream, it is in this bit of junk. Is it this one? Nope. All right, let's try another one. A lot of times it's just kind of walking through it. Oh, right there. That one?
Yeah.
And you'll notice you now have the option for follow SSL stream. Yeah, here it is. So in this giant thing of Facebook has, it's enormous. We'll scroll through and really it's just kind of until you see it. It's around here somewhere. There we go. Here's the actual message. And this was meant to be brutal on you guys. I'm sorry. I felt like 1 and 2 were like a little easier, so round 3 was meant to like make you cringe looking at all this Facebook traffic and not be able to use strings or ngrep. As we look through it, we'll see the actual conversation that he sent to Keel. Here's another place where we can see what his name is, Clarence Darkwater. You could have also gotten it through the profile ID, as was previously mentioned. We can see his conversation and why. Oh, there we go. We can see his conversation right here that says, "It was great meeting you today. You have put up the highest bid. I will be selling you the formula. Transfer the $200 million into this account. Once the transfer is complete, I will send another message with instructions where you will receive the package containing the formula."
You never got your Facebook account shut down because of that.
Probably.
You can actually copy and paste it to a notepad and save it as HTML and open it with a browser.
Really? Nice. So that's a separate way you could have done it. If you guys didn't hear, he basically said you can copy and paste all of the code into a file and just open it up in a browser. Also effective. And we can see he is typing, right there is Keel, which is the response, and we can see the other profile ID right there. I know some of you are like, I did this in such a complicated way that was way too hard. But there's multiple ways to answer everything. Fun fact, and I'll leave this to you guys. Well, let me answer these two first. What is the purchaser's display name? Keel. And the account number that Clearwater did tell the buyer to deposit the money into, which is right there. Wait, where'd it go? Right there. So there's a little bit of an Easter egg in this one. I found out Facebook, if you friend somebody, it just starts spewing names everywhere. So if you can find me in this packet capture, my Facebook ID is in there. I will friend you if you can find me. It's in there. I initially meant to friend Darkwater as like a joke, and then all of a sudden I'm starting to see like updates, and then like Darkwater starts suggesting my friends. Facebook's really sketchy that way. So in any case, I've got a couple more prizes up here. So I'm going to ask a few more questions, but for right now, do you guys have any questions on this? You stoked? Had a lot of fun? Nice. Okay. Well then, I gotta think of some bonus questions. Yeah.
What if this was a Gmail talk where they use Hellman, we will be able to decrypt it, right?
It's been a while. I know you used to be able to decrypt GTalk because it used SSL TLS as its transport layer, and you had to change some things in terms of port and communication protocol. But that was like a year and a half ago.
Now they're using Diffie-Hellman as encryption. So
Nice. Well, one of the great things is now you can research. See if you can find a way around that. That's something I'd be really interested to hear about. But in terms of, I've got 3 prizes left. Do you guys just want, I'm trying to think of some good questions right now. All right. What's a good one? Okay. 1 prize goes to someone that can think, for Silly Putty, who can think of a really good question? Is that kind of a cop-out for me in the back?
Will the 1337 pill quickly partly be money?
Ooh, that is a great question. You can have Silly Putty for that. I'm not going to throw it that far. I'm going to hit the chandelier. Or somebody. I don't even have an answer for that. All right, real quick, if you guys have your Wiresharks open, name 1 friend that was suggested. No, that's too much. There you go. Man, it's tough coming up with questions on the fly. All right. Someone name the BPF filter for just UDP packets. Yeah, like so what would be a filter that you could type into Wireshark that would give you only UDP packets? Yep. Sorry, he beat you out by just a second. Oh, yes! This is great. I haven't killed anyone by throwing prizes yet. All right. And last, for the Swiss Tech utility key. Drum roll. Oh, here's a good one. And this is going to be a real race. What date is Network Forensics Black Hat nice going to be happening in the USA? 21st of July. You were close. Whoop. Yes! All of them. All right, well, guys, thank you. I hope you had fun. We're going to be doing this again in USA. And forensicscontest.com, there's going to be some more stuff up there as time goes on. So thank you. Yep, the files that were on there.
Quite nice.
Yep. Oh, I think you can keep this if you want. Yep.
Okay, thank you very much.
Welcome. Yes. Yeah. Yep, go for it. And actually, just for everyone that's in here, we've got some more time. So I think there's a break going on right now. Yeah, there's a break going on right now, and we've got another half hour. So if you're interested, I'll go over some of the stuff that's on the DEF CON CD. I'm going to be here, so we might as well do some more if you guys can handle it. Huh?
You will continue with some demonstration?
Yeah. Yep. I mean, if you're, I'll keep going, but I know there's other presentations going on too. Yeah. That one's paid for. Yeah. So at 5 o'clock, I'll be going over the DEF CON stuff if you're interested. So share with people. It's kind of underground, but yep. Go get some coffee, and I'll start at 5. All right. I'm going to begin. So this is the second part of Mobile Network Forensics. Mobile Network Forensics Reloaded. The speaker, as far as I know, for Opcode's database revival won't be coming, so we're going to be continuing on with Mobile Network Forensics. For anyone that's new joining us, we've got some files, some DVDs up here that you can get, and we can go through and look at some packets. These DVDs are from DEF CON 2011, and it was a contest created for people there. I think the fastest person to get it done was around 5.5 hours, so We're not going to make it all the way through, but it's definitely going to be hopefully entertaining and useful for you guys. If you're just coming in or you don't have the files, load them up from the DVD. Try and find someone that's got a DVD around you. I only brought a limited amount, but I've got 2 more up here. They've got instructions on how to do it and go through, and I'm just going to kind of go through the opening for you, and we'll go from there. All right, so I will begin. Everyone here, we're doing some forensics. So we're continuing on. The earlier portion, the mobile network forensics, was on lockdown for Black Hat. We're kind of extending that a little bit. I brought some CDs from DEF CON, and we're going to take this to the next level. So I hope you guys are ready, prepared for some advanced, but hopefully really enlightening and fun network forensics. So to begin, everyone should either have a DVD or the files for the contest. If you don't, I ran out of DVDs up here, but there's enough of them floating around in the crowd that I would ask that people are willing to share. And what you get on the DVD is, or the files, is right here. And so we'll see that there's 6 contest files. And if you look through it, you'll see that contest 1 is decrypted, and then contest 2, oh, are all these decrypted? Oh, handy. Oh, sorry. I got ahead of myself. Oh, this is really nice. Okay, so I didn't realize. Past me was really smart about things. This DVD actually contains the canonical amount of contests that we have ran. So you'll see that there's contests 1 through 6. These were posted online over the series of a number of months and posted as competitions for people to win prizes in solving each one. You'll notice in each contest file, there is an evidence01.pcap. We've included all of the finalists and the puzzle itself. So going through, you'll be able to double click on the puzzle, and let me drag this over. Each one gives a scenario along with the packets. So the very first contest ran was called Anne's Bad Aim. And as we read through it, I'm just going to read through this one. I think rather than starting with the DEF CON one, it's best to start with captures 1 through 6. They're already decrypted. They're ready for you guys to advance and learn. This is actually a pretty good logical continuation of what we just taught over the last hour. How many new people joined us just now? Welcome, guys. Over the last hour and a half, I went through network forensics, kind of the basics of it, and had a contest for that. This is the kind of expansion. We're going to be going over some more advanced packet captures using some tools that were created by people. If you've got a laptop, I welcome you to follow along. We should have the files floating around if you're interested, and if you have any questions, please feel free to come ask me. So let's all begin with number 1, Anne's Bad Aim. If you've got it loaded up, you'll see that Anarchy R Us suspects one of their employees undercover is really a secret agent working for their competition. I'm going to move this on my screen so I can read it all. Anne has access to the company's prize asset, the secret recipe. Security staff are worried that Anne may be trying to leak the company's secret recipe. Security staff have been monitoring Anne's activity for some time, but haven't found anything suspicious until now. Today, an unexpected laptop briefly appeared on the company's wireless network. Staff hypothesized that someone may have been in the parking lot because no strangers were seen in the building. Anne's computer, IP address 192.168.1.158, sent IMs over the wireless network to this computer. The rogue laptop disappeared shortly after. We have a packet capture of the activity, said security staff, but we can't figure out what's going on. Can you help? You are the forensic investigator. Your mission is to figure out who Anne was IMing, what she sent, and recover her evidence, including the name of Anne's IM buddy, the first comment in the captured IM conversation, the name of the file Anne transferred, the magic number of the file you want to extract, the MD5 stum of this file, and the secret recipe. And it lists an evidence file as well as the MD5 sum of it. The end says that the most elegant solution wins. A lot of competitors made applications that would solve these for you. When you're going through this, it requires you to analyze it either in Wireshark, ngrep, or whatever tool you choose. Tools are included. If you look over here in the finalists, you'll see a number of tools. Eric Heimlevek, creator of the Network Miner, is also a great tool, and it has progressed a lot when he was answering our contest. So I'm going to give you guys a few minutes to go through evidence1.pcat. As part of this, you're going to be carving out files, analyzing conversation strings, and basically just taking a look at it. So if you have any questions, feel free to ask. As soon as someone gets the answer, I'll probably take a stop and show how to do it. Any questions as of right now? Cool. Go for it. All right, I'm going to go ahead and do a walkthrough of this one just so that I can give you guys a chance to see how it's done and then hopefully get started on round number 2. Does that sound good? Any objections? Okay, cool. So I copied my evidence over just to my desktop so I can take a look at it. And actually, let me get my questions up so I have access. So question 1 was, there we go. What is the name of Anne's IM buddy? And actually, these two go well together. What is the first comment in the captured IM conversation? Did you guys raise your hand if you got that answer? A good portion of people. Of the people that got the answers, what did you use? Strings. Wireshark. Yeah, strings is dirty, but that's what I did. So it's really easy if you just go strings, evidence, and then pipe that to less. And this isn't necessarily the best way to go about it, but it is a quick way to kind of get a feel for a packet capture. And if we do that, we see instantly right at the top, sec558 user 1. Here's the secret recipe, ellipses. I just downloaded it from the file server. Just copy it to a thumb drive, and you've got it. Oh, and you're good to go. So right there, that solves 1 and 2 by using strings. Now, you could have found this also through Wireshark, but you know, it was pretty quick. It was pretty easy to go through for strings. The next question is, what is the name of the file Anne transferred? Anybody know? Yep, recipe.docx. Again, if we're cheaters, we can do strings, and then we can search for, was it a txt? No. Was it a PDF? No. Wait, docx? Let's try doc. Recipe.doc. Again, not the most efficient way to go about things, but in a contest setting, it's definitely very quick. Another way you could have gotten it is by looking in the actual packets in Wireshark, and you'll see in the information recipe.docx in there if you follow the TCP stream. So there's that one.
So just for niceness, you would prefer manually going through every packet and see, ooh, there's the .x file.
No, I mean, yeah, that's. I think the best way would be to use ngrep, and if you're searching for things, you could search for, you know, txt or but that's more useful when you know what you're searching for. Oh, hold on, I must have entered that. Oh, there's a space. And it'll actually show you that docx is in there. I would definitely say ngrep is probably the best way to go about it, but sometimes with open-ended questions like what was the file, you know, you could also set it up a script so it iterates through all popular file format extensions and see, you know, are there PNGs, PDFs, docx's, etc. Yeah. Oop, this is asking for a question. There we go. And that's probably the easiest way to go about doing that. Did anyone have a different way that they went about it? Yeah, I mean, strings is just really quick, and grep is really quick. They're both really nice. So now we're on to what is the magic number of the file you wanted to extract? Yes? Nope. Oh, wait, maybe it is. Let me check. In hex, please. I don't know what the actual ASCII is. Yep. And the easiest way to find that is to just search for magic number docx. Yeah. So that was a pretty quick one to find. And I somehow, there we go. So now that we know the magic number, that's kind of a leading question. Because what do you need to know the magic number for? I mean, how many of you are familiar with magic numbers? A couple of people. Magic numbers are a way within a file system to identify a file type. It's like magically I know that these numbers are the beginning of a docx. And so now that we know the magic number, what's something that you could do now that you know what a docx starts with? Yeah, search for the docx's. So the next easiest way to do that is, I think the easiest way is probably going to be in Wireshark. If I can, oh, there we go. Yeah. Yes, that is dangerous. And I'm just going to go ahead and open that off my desktop. So within here, where was that? Is it here? That's the conversation. Let me clear that out. Sorry, I was half doing this in my Mac and the other half was in my, oh, here we go. In Backtrack. Here we go. So looking at this, we can see, here's the second way that we could have found the file name is it's recipe.docx. If this really, really long window all the way over there, recipe.docx. So with this right now, basically what we want to do, and this is vaguely evil of me because a lot of the things learned in here are taught in SEC 558 or network forensics books. But this requires you to actually carve the file out of the network capture. And this is pretty fun. I mean, if you played around with packets, it's a fun little aha moment when you carve your first file out. So if we're looking through, we're going to want the actual hex of what's going on here. And so what we're seeing is OFT2 at the very beginning. What's OFT2? What? No. Yes, the Oscar file transfer protocol. Because OFT2 is 4F465432. And so Oscar file transfer protocol is what AIM uses to transfer files. So we now know what the communication protocol being used is. But when we look through it, okay, so here's recipe.docx. Do we see the magic number in here? If you look at your own, probably not. So we scroll down. Oh, that looks familiar. Is that the magic number? Yeah. So I'm kind of leading you guys on. I know the answer. So now we've got the answer. But when we're looking through it and we just pick one side of the conversation, we end up with a bunch of stuff that we don't need. So what I'm going to do is I'm going to turn it back into raw. Now that I know that the file that I want is in here, and I'm going to save it. So I'm going to save this as recipe. My spelling is terrible. I'm going to start that with an F. I'm just going to start it as r.raw, so I don't have to spell it. Save. So I've just exported just this one portion of the conversation of .158, like 192.168.1.158 to 192.168.1.159. But I've got some junk in there that I don't want, right? Because I don't need that Oscar protocol. And if I just try and open this, it's going to have an issue. I mean, let's take a look at this. If I just try and double click on that, it doesn't know what to do with it. I mean, the file is in there. We know it is, but we need to clean it up first. So I'm going to pop open my favorite hex editor, and that is Bless on Linux. And then open up my raw file. And we can see I'm back up just like I saw in the Wireshark, the hexadecimal. And I don't want all of this stuff. This is all just junk as far as I'm concerned. What I'm really looking for is that magic byte. Oh, that starts right there. Because all I care about is the magic number where the docx starts. So in all reality, right here in the hex is where the docx that I want starts. Which means, oh, I don't want to delete it though, that I can take everything before it and delete it. And when I do that and I save it, oh, well, let's try this again. Save. What am I doing wrong here? Oh, there we go. Save as. Gotcha. I'm going to save it as r.raw. docx, so my operating system knows what the file is based on the file extension. So just by saving this hexadecimal as the docx and removing everything before, I can see that, at least in Backtrack, it identifies it as an OpenOffice document. And OpenOffice can open docx files. So when we double click on it, I might have to do this on my Mac. What are we doing here? Thank you, Backtrack. All right. What I'm going to do is I'm going to go single window, drag my r.docx into Mac, and then give a double click there. Oh, sorry, it opened up off screen. So when I open it, Shazam, we've got a recipe for disaster. And for you guys that can't read, that is 1 serving ingredients of 4 cups sugar, 2 cups water. In a medium saucepan, bring the water to a boil, add sugar, stir gently over low heat until sugar is fully dissolved. Remove the saucepan from the heat, allow it to cool, pour into a gas tank, and you have a recipe for disaster. Nice. Do you guys have any questions on how I went about doing that or anything? Yes?
Aren't you worried that in some cases there will be a trailing header or something behind you as well? So this will be worse. This start from the beginning and then you have something at the end as well.
I find typically for file transfers, there's not anything at the end.
Just the header and that's it.
Yes. Yep. For the way that the packets are transferred, I guess. Yep. I'm sorry, I can barely hear you. Oh, so the question is, if I understand it right, if I've got a really large PCAP file, how am I going to carve things out of that? Typically, you can run it through different types of analysis software. I would say if you look through here, there's a number of tools that were written. What some of these people did, Jeff Jarmuck wrote a Perl script called Grouch that will automate all of these questions. It's kind of single use. I don't think very many people are transferring docx's over AIM. But if you're looking for something like that, scripting and knowing a scripting language is incredibly useful for going through it. I know Eric Hemivek, I hope I'm saying that right, has done a lot of work with Network Miner so that it can handle really large PCAP files. And you can, it makes it too easy. You can just, it automatically notes every type of file. You can just drag it out, open it, save it as, etc. I think that's necessarily probably the most efficient way is automation through tools. If you're trying to do it manually, it's beneficial to a limited extent, but I would probably say the best way to do that would be to automate in the PCAP file, exporting out the conversations that you want that have the files that you want, and then automate the carving of the actual hex. Yep, Network Miner is a great choice. Yeah, and it's almost everything that I just showed you. You could, just double-click on Network Miner, drag this evidence file into it, and it would pretty much give you all the answers. So that's just usable. But it's much more fun to impress your friends when you're like, check it out, I'm going to carve some files out. And a lot of this is actually also useful for file system forensics as well, because the same way that we're carving out files over network traffic, you can carve out files on a disk. Cool, so let's start off on round 2. Let me clean this up a little bit. So there's contest 1, contest number 2. All right, puzzle number 2, Anne skips bail. After being released on bail, Undercover disappears. Fortunately, investigators were carefully monitoring her network before she skipped town. We believe Anne may have communicated with her secret lover, Mr. X, before she left, says the police chief. The packet capture may contain clues to her whereabouts. Again, you are the forensic investigator. Your mission is to figure out what Anne emailed, where she went, and recover evidence, including what is Anne's email address, what is Anne's email password, what is Anne's secret lover's email address, what 2 items did Anne tell her secret lover to bring, What is the name of the attachment and sent to her secret lover? What is the MD5 sum, city and country, and another MD5 sum? So again, I'm gonna let you guys go forth, play around. Hopefully there's gonna be some more file carving. So having watched this, hopefully I'll be able to carve some more things out of the next packet capture. Again, if you have any questions, just let me know. And if you have no idea what you're doing, I suggest opening up the finalists folder and playing around with some tools, because that'll probably give you the answers. All right, and we're not going to have enough time to get through all of it, so what I'm going to do for you guys is, and I don't recommend going here until you're done, but if you go to forensicscontest.com as you're doing these, if you have any questions or want to know the answers, if you just go to the home, I would lose my internet while I'm trying to show you something cool. All right, and then you go puzzles, and then under puzzles, it will have the actual puzzle, the answers and winners for each one. So as you're going through, if you want to go forth and do more and find the answers to this, they're all right there. But as for that, that's going to wrap up this last hour. So thank you guys for sticking with it. You are becoming super elite.